So now we are going to learn to implement the ordinary least squares regression from the first principles with Pytorch, and I'm going to give you a very basic and basically a toy example to just show you how we can set up the ordinary least squares regression in Pytorch from the first principles. So now you can import torch, import torch.optim as optim, torch nn as nn, numpy as np, and matplot.pyplot as plt. Now the input size is going to be 1, output size 1, because essentially we are going to just have one x variable and one y variable, and obviously we are more likely to have more x variables with real data, but this is a toy example. Now num epochs, which is the number of epochs, we are going to set that to 10,000, and the learning rate will be 0.001. So now we are going to create a training and a test data set, x underscore train and y underscore train, and we are going to create a numpy kind of a data set. So x for predictors, predictor, and y for response variable. I create a variable model nn.linear. So from here, nn, I call the function linear for ordinary least squares regression, input size, output size, which is basically, which refers to the size of the predictors and the response variable, which is 1 and 1 in this case. I'm going to define the loss function in terms of mean square error. Again, I'm going to call it from the same package. You can even use RMSE, but mean square error is just more robust. And then we are going to have a gradient descent for the optimizer, optim.sgd, stochastic gradient descent, model.parameters, learning rates, and then for epoch in the range, number of epochs. So we are going to iterate through epochs. We are going to feed in the inputs, x train, and we are going to convert. So torch from numpy. So we are going to convert numpy to a tensor. And same outputs, model inputs, loss criterions, outputs, and target. So basically we are going to compare the output with the target, the output we obtain with the target. So basically compare the predicted and actual y. Optimizer.zeroGrad, loss backward, optimizer step, and till we reach, so for every 1000 steps we print the result. So 1000 out of 10,000, this is our mean square error loss, and we continue to till here, and we can see the loss has declined. Now we are going to use this model to predict on our data. Predicted model, torch from numpy, x detached numpy, and now we are going to plot x train versus y train, which are our original data in y, and x train comma predicted, and predicted is the predicted response variable, and that's something we had created before, which we obtained from here, predicted, which is the predicted y. So, and this is these are the predicted data, and as you can see, they do seem to be tying in quite closely. And anyway, this is just a toy example. So now you can see that this is how we would set up an ordinary least squares regression problem in Pytorch with first principles.